Welcome to Ask and Learn.
Burning methane and oxygen can produce 3 different carbon-containing products. We'll answer parts A and B together. We're going to write 3 balanced equations for the reaction of methane gas with oxygen to produce these 3 products, assuming water is the only other product, and we'll also determine the standard enthalpy for each of the reactions in part A. So we'll do A and B together. Our first reaction, number 1 here, is CH4 plus O2 to produce carbon and 2H2O. And for this, we'll determine our delta H naught reaction, which is the enthalpy of formation of the products, minus the enthalpy formation of the reactants. This is equal to the delta H naught formation of carbon solid plus the delta H naught formation, we'll back it up here, 2 delta H naught formation for H2O liquid minus the delta H naught formation of CH4 plus the delta H naught formation of O2 gas. Substitute our values in here. Delta H naught formation of carbon is 0. H2O liquid is negative 285.8. Delta H naught formation of CH4 is negative 74.8. Delta H naught formation of O2 is 0. And this works out to negative 496.8 kilojoules for our first reaction. For our second reaction, CH4 gas, 2O2 to produce CO2 gas and H2O liquid. Delta H naught reaction is equal to delta H naught formation of the products minus delta H naught formation of the reactants. This is equal to delta H naught formation CO2 gas plus delta H naught formation H2O liquid minus delta H naught formation CH4 gas plus 2 delta H naught formation O2 gas. Delta H naught formation of CO2 gas is negative 393.5 kilojoules. Sorry, this wasn't balanced. There's a 2 there, which means there needs to be a 2 here. Plus 2, negative 285.8 is the delta H naught formation of H2O liquid minus delta H naught formation of CH4 is negative 74.8 kilojoules, and delta H naught formation of O2 is 0. This works out to negative 890.3 kilojoules for the delta H naught reaction for number 2. And for reaction number 3, we have CH4 gas, 3 halves O2 gas, which will produce CO gas, 2H2O liquid, delta H naught of reaction is equal to the enthalpy of formation products minus delta H naught formation reactants. This is equal to delta H naught formation CO gas plus 2 delta H naught formation H2O minus delta H naught formation CH4 plus 3 over 2 delta H naught formation O2 gas, and the delta H naught formation of CO is negative 110.5 kilojoules plus 2 delta H naught formation of H2O liquid is negative 285.8 minus delta H naught formation of CH4 is negative 74.8. Delta H naught formation of O2 is 0. This works out to negative 607.3 kilojoules. So here we have 3 different reactions for CH4 with oxygen, producing 3 different products, and the delta H naught reaction for all 3. So we've done A and B in for both parts already. In part C asks why, when the oxygen supply is adequate, is CO2 the predominant carbon containing product. So when an excess amount of O2 is present, then carbon dioxide is formed as a product which has the most negative enthalpy value per mole of CH4, hence CO2 is the most thermodynamically stable product.